Recording, yes, okay. So this is section 8-5. We're skipping over 8-4, which is applications. And these are called quadratic like equations. Like equations. They, in the book they call it equations reducible to quadratic form. So if you see something that looks like this, if you see something that looks like this, x to the fourth minus 13x squared plus 36 equals 0, okay? All of these kind of work the same way, okay? You do something called U substitution, okay? So what you do is, see how it kind of looks like a quadratic, but it's got a fourth there instead of a square? You do what's called U substitution. So you say let U equal, usually this second thing right here. I'm going to let U equal x squared. I'll show you the way this works. If U equals x squared, then what's x to the fourth equal to? If U equals x squared, then U squared, okay? So once you know what you let U equal to, which is usually this second thing right here, because they're all going to be a little bit different, then U squared is x to the fourth. So then I could rewrite this equation with this being U squared, this being minus 13U, and this being plus 36. Do you guys understand what I just did? Yeah. Okay? That's called U substitution. And then you factor this if you can. Okay? If you can't factor it, you'd have to use quadratic formula. Usually, these will factor. What two numbers multiply to 36 and add to negative 13?
9 and...
Yep. Negative 9 and negative 4. Okay? And then you go ahead and you solve this like you normally would. So you get U minus 9 equals 0, U equals 9, and over here you have U minus 4 equals 0, U equals 4. But then you have to do something called back substitution. You said, well, what did I let U be? I let U be x squared. So now you substitute this back in for U. Okay? It's called back substitution. So you sub back in, and now you have x squared equals 9, and here you have x squared equals 4. And so if x squared equals 9, what's x equal to? 3. Plus or minus 3. And here x equals what? Plus or minus 2. All right? And you really need to check your solutions to make sure they work. I think these work. And if I plugged all these numbers in here, I get the right answer. So that's how you do that one. Okay? Are you ready to try one? Ready to try on your whiteboard? Okay. You try. You try.
You try.
Okay. You try. Who try? You try. Okay. X to the fourth minus 11x squared plus 18 equals 0. Okay. So see what you come up with that for that one. How many minutes did you have? All right, so we're moving on to a problem that kind of looks like this. X squared minus 7 squared. And, you know, these problems are kind of weird. When someone asks, when would you ever see these in real life? Probably never, you know, but it's part of the curriculum, so that's what I'm teaching. But these types of problems do come up, in like Algebra 2 and and pre-calc and stuff like that, and you still need to know how to do them, okay? Very similar situation. You just still do a U substitution. What should I let U be? Keep going. No, so see how it's like x squared minus 7 squared minus 3 times x minus 7 squared plus 2. Who thinks they know what I should let U be? What do you think, Adam?
X squared minus 7.
Yeah, so because there's an x squared minus 7 here and an x squared minus 7 here, you let U be, okay, let U equal x squared minus 7. Okay? Okay, so here we go. So then you just do U squared minus 3U plus 2 equals 0. And you factor that just like I did the last one. What does that factor to? What multiplies to positive 2 and adds to negative 3? Negative 2 and negative 1, right? Equals 0. And then you draw your little squiggly line. U equals 2 or U equals 1, right? And then you do your back substitution again. And so we come in here and we say, what did I let U be? I let U be x squared minus 7. So I say x squared minus 7 equals 2, or x squared minus 7 equals 1. And then you have to still solve those equations independently. Add 7, I get x squared equals 9. X equals what in this case? Plus or minus 3, right? X squared equals 8. Is that right? X squared equals 8. X equals what? Plus or minus square root of 8, which can be written as plus or minus 2 root of 2. Do you remember that? That can be written as 2 root of 2. Okay? And that's how you do that. You ready for a U-try?
Yeah.
Okay. Your turn. So this one comes out, I gotta warn you, with some imaginary solutions. But still, they're not bad imaginary solutions. So you try. You try. Shut up. Okay. N squared plus 6 squared. Okay. Minus 7 times n squared plus 6 plus 10. Plus 10 equals 0. Okay? So try that one, see what you get. All right? Oh, it's recorded. This one I have seen in Algebra 2, in pre-calculus and calculus. So you need to try to focus here. X to the 2/3, okay? Plus x to the 1/3 minus 6 equals 0, okay? So this one is a little different form, but it's really the same idea. You have to let U be something, okay? Guess what I should let U be?
X to the 1/3.
Yeah, let U be x to the 1/3. The reason for that, please, Charlie and Ponder, look up on the board, okay? You let U be x to the 1/3 because if I take x to the 1/3 and I square it, what do I get? What's x to the 1/3 squared equal to? What do I do with those exponents? What's x to the 1/3 squared? X to the 2/3, right? Which is what I have over here, right? So you let U be x to the 1/3, and you let U squared, therefore, is x to the 2/3. See that? Huh? So now what you do is you do your u substitution again. Okay? U squared plus u minus 6 minus 6, not equals 6, equals 0. What does that factor to, Hayden? What two things add to 1 and multiply to negative 6?
The negative 3 and, oh wait, 2 and 3.
Yeah, which one's positive, which one's negative?
3 is negative.
Isn't
Isn't it negative 1? Oh, no.
it's positive one, right? So which is positive?
2. Negative 2, positive 3.
Right, negative 2 and positive 3, okay? That means that either u equals 2 or u equals negative 3. Now this is where it gets a little bit tricky. You do your back substitution, okay? So you say x to the 1/3 equals 2, or x to the 1/3 equals negative 2. How do I get rid of that 2 there? What? Sorry, negative 3. Okay? How do I get rid of that? How do I get rid of that exponent? How do I find x if I know x to the 1/3? Raise it to the what power? Third power. So I have to raise this to the 3rd power as well. So x equals what? What's 2 to the 3rd power? 8. Okay? Here I have to take this, raise it to the 3rd power, and then I raise this to the 3rd power. So you get x equals negative 3 times negative 3 times negative 3. What's that? Negative 27. Okay? So that's pretty tricky, right? Yes, sir.
Why would it be not be
No, because negative times negative times negative is a negative, right? Because negative times a negative is a positive.
Yeah.
Times a negative again, makes it negative. Okay, was that your question, Calvin?
No, but
Okay. So we're going to do another you try, and then I'm going to put you into pairs. We're going to try something different with the pairs, okay? You try this one. Got to try this wheel, okay? M to the 1/2 minus 5m to the 1/4 plus 6 equals 0. Okay? You try. Ian, you try. You try. Gotta try. This one. So did you let u equal m to the 1/2? No, m to the 1/4, right? Okay? So that means that u squared is equal to this times 2, which is m to the 1/2. Yes? Hello? And then you rewrite it and you solve it. You end up getting u equals 16, or sorry, m equals 16, or m equals 81. Okay? All right, so we've been doing process, but it requires even more steps, and you definitely have to check your answers on all of these, okay? So say I were to see something like this, x minus 2 root of x minus 6 equals 0. Okay? I'm going to let u be something again, okay? Let u equal, guess what? Root of x. Because that means that u squared would be what? X, okay? So again, the factoring part is not that bad, okay? So u squared is x. So here, in this case, you're plugging in a u squared for x minus 2u minus 6 equals 0. Charlie, turn around. With these ones here, okay, is there anything that multiplies to negative 6? Oh, maybe there is. No, there's not, is there? Does anything multiply to negative 6 and add to negative 2? No. Okay, so what do I do if nothing adds or multiplies to that? I have to use something else. I use the quadratic formula. Okay, this is where it gets this is where it gets kind of tricky, okay? U equals negative b 2 plus or minus the square root of negative 2 squared, right? B squared minus 4 times a, what's a in this case? 1 times c, which is negative 6. The whole thing divided by what? 2. Okay? This is 2 plus or minus the square root of 4 plus 24. Is that right? 4 plus 24? What's 4 plus 24? 28. That whole thing divided by 2. You keep going with this because it's going to be easier when you do the back substitution. 2 plus or minus, how could I rewrite the square root of 28? 4 and 7. Square root of 4 times the square root of 7 divided by 2, which is equal to 2 plus or minus 2 root of 7 divided by 2, which is equal to, what can divide away from all of these? I can divide away a 2 from here, turn that bottom into a 1, turn this into a 1, and turn this into a 1. So now I just get equals 1 plus or minus the square root of 7. Okay, that's what u is. That's a long, long trip, right? Now, what do I do with that u? What's u equal to? Square root of x. So if u is equal to the square root of x, how do I find out what x is? What's x? X equals what? U squared, right? So x is u squared, so I'm going to take 1 plus root of 7, and I'm going to square it. And I'm also going to do that with 1 minus root of 7. 1 plus root of 7 squared is equal to 1 plus 2 root 7 plus 7, which is 8 plus 2 root 7. Do you think you could do this on a test? No, it's pretty. See, I just FOILed that, okay? 1 times 1, root of 7 times 1, root of 7 times 1 again gives you 2 root of 7, and root of 7 times root of 7 gives you that, okay? If I do 1 minus root of 7 squared, okay, I get, what do I get? 1 minus 2 root of 7 minus 7, which is negative 6 minus 2 root of 7. No, oh, you're right, plus 7. You're right, which is plus 8. 8 minus 2 root of 7. You're right. 8 minus 2 root of 7. There you go. Then, what you're supposed to do is plug these both in and make sure they work. Okay? X equals X equals. Okay? So if I take X equal there and plug it in, do they both work? Oh, you know what? This one, this answer you don't have to worry about. 1 minus root of 7. Because what's true about 1 minus root of 7? What kind of number is that? It's a negative number, and if I take that and I plug it in here, I get a negative number, so I throw this answer away. This answer I do use, and this is your only answer right here. Should I try, you try, or should we skip that one?
Skip.
What? You just want to what?
So he just wants to do homework.
You want it? So, okay, but I'm going to take you through a couple more examples. I'm not going to do you try on that one. I just want to, I want to show you a couple more things you're going to see. This one, you're going to see one that looks like this. I'm going to give you a you try on this one, okay? Not yet, okay? So But here's another type you're going to see. X to the negative 2 minus 5, not x, sorry. No, that's right. 2x to the negative 2 plus x to the negative 1 minus 15 equals 0. Okay? We're going to do another let u equal something. What should I let u be in this case?
X to the negative 1.
X to the negative 1. That means that u squared is? What's x to the negative 1 squared? What's x to the negative 1 squared? X to the negative 2, right? So again, I do the same type of thing. Okay? I end up with a quadratic that looks like, in green, because it's St. Patrick's Day, 2x, 2u squared, sorry, okay? 2u squared, 2u squared, plus u minus 15, okay, equals 0. So this one, you could use the cross and box method. Hey, but I'm not going to use the cross and box method. Who knows what has to go here and here? What has to go here?
U.
2u and what? U. Because that's the only thing that can multiply to 2u squared, right? Now I have to figure out two numbers that have to go here and here that multiply to negative 15 and I have to positive u. Anyone guess what goes here and here? What multiplies 15? 3 and 5 or 15 and 1. Those are your only choices. What if I put a 5 here? Is this going to work? 3 times that is 6. 5 times that is 5. Oh, that works, doesn't it? Okay. Which should be negative, which should be positive? Which is negative, which is positive?
Why does that work?
Plus, minus, right? 3 times negative 5 gives you negative 15. 3 times 2u would make 6u, right? And negative 5 times u makes negative 5u. And those add to that. You could have also, remember the cross and box method that we did way back when? You would have to do the cross. What goes in the top of the cross is negative 30. What goes down here is 1. Two numbers that multiply to negative 30 adds to 1 are 6 and 5, I believe, right? And this is positive, and that's negative. And then you would draw your box over here. Remember this? And you put your 2u squared. I was just trying to kind of avoid this. Your negative 15 over here. You put your 6u over here. And your negative 5u over here. And then you pull out a common factor, 2u. Put u minus 5 and plus 3, right? This was that cross and box method. Those are those two factors. See it? U plus 3, 2u minus 5. You guys remember that? Okay. So in any case, then I solve this, okay? I say 2u equals 5, which means that u equals what? If I set this equal to 0. What's u equal to in this case? What's 5 divided by 2? Hello? 5 over 2, okay? Here I say u plus 3 equals 0. U equals negative 3. And what goes here? So what I let u be? I let u be x to the negative 1. X to the negative 1 equals 5 halves. X to the negative 1 equals negative 3. Who knows what's x if x to the negative 1 is 5 halves? How can I rewrite x to the negative 1? How can I rewrite x to the negative 1? 1 over, 1 over x equals 5 halves. Okay, and 1 over x equals negative 3. If 1 over x equals 5 halves, that means that x equals 2/5. If 1 over x equals negative 3, that means that x equals what? Negative 1/3. Okay? Those are my two answers after all that work. Okay? And you have to take those, plug them in, make sure they work. And I'm not sure if both of those work. We'd have to take them and plug them in. Okay? I think you guys have had enough. You've had your fill, haven't you?
Yes.
Okay. So I'm going to start you on the first homework assignment, okay, which is on the first stuff we learned, page 537. I do want you to get started. You have 20 minutes, okay? 537, 11, 13, 19 through 21, 23, 33, 35, and 37, okay? That assignment, I'm having the sub-collect tomorrow, okay? So make sure you do this one and get started on it now. And